Hi guys, in this video we're going to be looking at using Tinkercad to simulate an Arduino. Now the Arduino is a tiny computer. It has a microprocessor, and the microprocessor is on a board with these convenient pins. Now these pins allow us to supply power to other devices, to read from those devices if it's a sensor, and to control output devices as well. So the power pins are in the bottom left here, and then these pins on the right are called the analog pins, and those are connected to analog to digital converters. So we can connect a sensor to one of these pins, and the analog value will be converted into a number that the microprocessor can understand and use in the program. And then the program running on the microprocessor can send values to these pins, which can output data to some kind of output device. Now let's start off by just using an LED. So I'm going to grab an LED and drag it over here. Now an LED is really easy to set up. It just has a positive leg, which is the bent leg, and a negative leg, which is the straight one. So we connect the bent leg to pin number 7 on the Arduino, and we connect the straight leg to the ground. Now this makes an electronic circuit, because what's going to happen is when we turn on pin number 7, the electricity is going to flow out of pin number 7 through the LED, which will make it light up, and then back to the ground pin. Now if we click on code, we can see the program code that is currently on the Arduino's microprocessor. And if you drag an Arduino over to the left hand side, then it might have some code already, but I'm just going to delete that code because we want to start from scratch. Okay, now if I start the simulation at the moment, the LED won't light up, and that's because the microprocessor doesn't have any instruction to actually turn on pin number 7. So pin number 7 is off at the moment, and that's why the LED is still dark. So if we want to turn on pin number 7, I go to Control, and I choose On Start, and then I'll go to Output, and I'm going to set pin number 7 to High. Now high means the same as on. So if I start that simulation, okay, I think this is just the website playing up a little bit. How frustrating. Is it my internet? There we go. Okay. So once I run the program, you can see that the LED lights up. Now, we're actually putting a little bit too much power through this LED because, as I said before, pin number 7 outputs 5 volts, and that's a bit too much for this LED. But since it's not a real LED, I'm not worried about breaking it, so I don't really care at the moment. Okay, so I'm going to click Stop Simulation. Okay, now, this turns the LED on. Let's try and make a flashing LED. So I'm going to go back to the code, and then I'm going to click on Control, and I'm going to use the wait command to wait a little bit, and then I'm going to turn the LED off again. So this is a program that's going to run on the microprocessor. So to turn the LED off, we set pin 7 to low. Then we need to wait again. Now at the moment this will only happen once, so if I start the simulation, the LED will turn on and then it will turn off, and then that's the end of the program. Let's make it repeat. So instead of using on start, I'm going to use forever, and then I'll just copy all of these into the forever block. So this will repeat these statements over and over. And I click start simulation, and there we go, it's going to flash on and off. Now we can change the speed of the flashing by changing the amount of time that the program waits. So if I change this to 0.5 and this to 0.5, and this means that the LED will be on for half a second and then off for half a second. So that means that it's actually going through a cycle once every second, and that means it's flashing at 1 Hertz. Now, if I wanted to flash faster at 2 Hertz, then I could change this to 0.25 and 0.25. That would mean that the LED flashes on and off once in half a second, so that would be twice in 1 second. So that is 2 Hertz. There we go, it's flashing quite fast now. Now let's say that I want to actually be able to control the speed that the LED is flashing while I'm running the program. So one way I could do that is to use a potentiometer. Potentiometer's over here. Let's drag it over and put it down the bottom. Now the potentiometer also needs to have a circuit, so I'm going to connect the left-hand terminal to 3.3 volts, and I'm going to connect the right-hand terminal to the ground. Now it actually doesn't really matter which way you do it, so I could have connected the right-hand terminal to the 3.3 volts and the left-hand terminal to the ground. It doesn't matter as long as you've got a circuit going out of the positive and then going through the potentiometer and then going out of the negative pin back to ground. Now what happens with the potentiometer is that the middle pin outputs a voltage which changes as you twiddle the dial. So I'm going to do a wire coming out of the middle pin and putting it into A0, which is our input. So this value that goes into A0, as I turn the knob on the potentiometer, is going to change, and the microprocessor can read that value. Let's just have a look at that on the code side. So on the code side, I'm going to get that value by making a variable to store it. I'll click Create Variable, and I'll call this pot for potentiometer. Now what I'm going to do is set the value of pot to the value on the potentiometer, which is here, read analog pin A0. Now this A0 matches the A0 here, which is connected to the middle pin of the potentiometer. Now to see what value the microprocessor is getting, let's just print it out. So I'm going to go down here and put print to serial monitor. And then the thing that I want to print on the serial monitor is the variable pot. So if I run the program now, what's happening is that the electricity from the 3.3 volt pin is flowing through the potentiometer, and a certain amount of that electricity is also flowing out the middle pin and going to pin A0. Now the Arduino can read that, and if I click on serial monitor, we can see the number that it's reading down here. It says 675. As I twiddle the knob, you can see that that value changes. So if I have the knob over this side, I get 0, which is the minimum. And then as I turn it, you can see that these values gradually change, and then the maximum is 675. Now what we could do is we could use that value to control how quickly the LED flashes. So instead of waiting 0.25 seconds, let's use the variable pot to change how much I want to wait. Now remember, the variable pot goes up to 675, and if I waited 675 seconds, it would be a very slow flash indeed. But fortunately I can change seconds to milliseconds here, and 675 milliseconds is still fairly quick. That's less than 1 second. So now if we start the simulation again, and you can see at the moment it's flashing on and off, and this is probably a little bit more than 1 Hertz. But as I move the potentiometer, we can make the flashing on and off faster and faster. And if I pull the potentiometer over too far, then what will actually happen is that the LED is turning on and off so fast that you can't really see it flashing. It just looks a little bit dimmer than if it was on full. As I turn the potentiometer back again, you can see the flashing slows down, and then gradually I get to the slowest on and off flash. So guys, that's how we can connect a potentiometer to an Arduino and then use that potentiometer value to change the rate of flashing. In the next video, we'll have a look at using other types of sensors.